Welcome back, students. In this video, we will discuss about electrical fuse and see the practical applications of Joule's law. So in the last video, we discussed the practical applications of heating effect of current, where we saw three examples: electric iron, electric fuse, and electric heating of lights. This video, we will discuss in detail about this electrical fuse, where the current, the heat produced due to current mainly depends upon the factor I square. So what is a fuse? Fuse is a safety device used in electrical equipments. So it protects your appliances and your house or wiring from damage due to excessive current. When there is excessive current, there is large amount of heat and there is possibility your equipment could damage. This fuse protects your equipment from such a damage. The fuse work on the principle of Joule's law of heating. Hence, we are discussing this along with this heating effect of current. So how fuse works? Fuse is made up of a alloy which has a low melting point. It has a low melting point. Why? Because it has to melt at the slightest increase in temperature. So it is made up of a low melting point, usually lead and tin, but your book covers aluminum as well as copper. So it is connected in series with the device it protects. So you have the switch followed by the fuse, then your washing machine, AC or heater, whatever you want to protect. So how fuse works? When the current is normal, the fuse wire carries the current safely. When the current increases, like we saw the equation, right? It is I square RT. When I becomes from 2 volts to 3 volts, the heat also increases to the square of the value. So when the current is very high, it could be due to overload or short circuit, more heat is produced in the fuse wire. The fuse wire becomes more heated, due to which the temperature rises. And since the wire is made up of a low melting point alloy, the fuse wire melts immediately. Because the fuse wire melts, the circuit is broken. There is no flow of current beyond the fuse and your equipment is protected. So let us see how the image of whatever I said now. So this is a view of a fuse and whatever you see is a live wire current, and the current passes from here to your device. Okay, and this fuse wire, whatever you're seeing here is the thin metallic wire made up of tin and lead having low melting point. When the current flow increases and becomes heated, because of the low melting point, this fuse melts immediately and breaks the circuit, meaning the current cannot further pass. So the fuse is how the fuse is constructed actually. This fuse is again covered in your next chapter as well. So let us see one or two extra details. The fuse is enclosed in a cartridge made up of glass, plastic, or in the earlier days there used to be even the porcelain materials. And both the ends there is a metallic cap for electrical connection, because that electrical connection only carries the current through the fuse. And the fuses carry a rating like 1 ampere, 2 ampere, 3 ampere. So what is the amount of current flows? That equivalent amount of fuse you need to have. So in an image it looks like that. So whatever you're seeing here, this is a thin metallic wire. Okay, these ends are the metallic caps which I told you. These metallic caps which carry the current through the fuse wire. And these are the ratings I told you, right? 5 amperes, 3 amperes, 13 amperes, and so on. These are the different ratings of a fuse. So how do you calculate the fuse rating? See, electrical iron, there's a 1 watt, 1000 watt power electrical iron at 220 voltage. In India, it is 220 or 230 voltages. That is the potential difference in India. So you know the formula. Current is equal to based on the Ohm's law. This is derived based on the Ohm's law only. Current is equal to P by V. P is the power. Power is equal to IV. Power is equal, formula is power is equal to V into I. So not Ohm's law, I'm sorry. This current I is equal to power by V. Power is 1000 ohms, 1000 watts. That's here. And voltage is 220 volts. So when you divide, you get the current that passes through the circuit as 4.54 amperes. So you won't get 4.54 amperes fuse, but you go for the nearest rating. So 5 ampere fuse, you put a 5 ampere fuse in the circuit, and as long as the 5 ampere current flows, your electrical iron is safe and current also flows the same way. When the current increases to 6 amperes or 7 amperes, the fuse melts immediately and prevents current flow to your electrical iron box and thus protecting your circuit. So in the next video, we will discuss the second application of Joule's law of heating, that is the uh, this thing, electrical bulb. That is the earlier we had the filament bulbs. We will discuss that in details. Thank you and bye till then.